Okay, assalamu alaikum students. And let's get started with Millis. We call this as Millis, Millis, right? So it is basically something you want to occur at the timed interval, right? So delay is the answer, but it's not going to work. So delay is not going to work every time, right? So for example, we type anything and then we give it a delay. So let's see an example of this. For example, let's create void setup and let's create void loop, right? So I'll begin my serial communication at 9600 baud rate, and let us say serial.println hello world, right? So this is something that we already know, right? So this is going to print serially, it's on the serial monitor. It's going to print it so fast, right? And and how is this basically happening? What are the timed events? What is a timer, right? We can either give a delay of 100 milliseconds, or let's say about a delay for a 1 second, right? So now there is a timer which is working behind, right? And this delay is basically good enough to learn the basics of Arduino or the basics of embedded system programming, but it is not going to work every time, right? Why? Because for example, if I have to print hello world only for let's say about 10 times or 8 times, right? So I will say for int I equals 0, I is less than 8 and I plus plus. So okay, so now what have I done? I have halted everything else here, right? I put my program on halt. So because my program is not going to do anything unless it prints it for 8 times. Okay, so once it prints it 8 times, then and only then it's going to do something else. Let's say about, I'll say hello again, right? And upload the code and see the response on serial monitor, right? Now we can see. So hello world will come for 8 times and it's not going to do anything else unless the hello world is printed for 8 times. Now we are having hello again, and while it's printing hello again, this is basically bypassed, right? So you're not going to do multitasking like this. For example, if I want to do multitasking, I want to fire many events, like I want to simultaneously read the value of LDR and at the same time I want to read the value of temperature sensor, because I am controlling, let's say about tomorrow, if you get a job of controlling nuclear power station, you have to get the value of temperature and increase the speed of fan basically at the same time, and at the same time you have some other events that you have to do, and for that we are going to get rid of this function delay. We're not going to use delay because it's putting our full system on halt. It's making the system paralyzed, right? So we are going to upgrade our programming skills of Arduino to the next level now, which is nothing but Millis, right? Millis is nothing but milliseconds, right? So it is an alternative name. It's basically a function in Arduino, an alternative to milliseconds, right? And how does it work, and what are the things that we are going to learn today? And we'll start with, as we already did, Millis overview, right? And number second is, what is the Millis timeline, right? So overview is not a function, Millis is a function, And number 3, we're going to learn handling events or handling multiple events with Millis, right? So this is basically what our target for today is, right? And what is Millis? I'll put a question mark here and I'll answer that. Something you want to occur at a timed interval. Something you want to occur at a timed interval, right? So you'll understand it in a much better way once I show you the practical of this. Someone is calling me again and again. All right, something you want to occur at a timed interval, and let us understand it by printing it. So let's start printing Millis, right? So let's call the function directly, and let's go to loop and say serial dot print millis. It's an inbuilt function, right? So I'm doing serial dot print Millis. I'll just try and increase the font. So increase the font, control plus. So let me increase the font. Okay, edit, control plus Y. Okay, so let me increase it. Okay, is it visible now? Much better. Okay, let me keep it like this. And now if I upload the program and run it, and you can see what is happening. You're getting some numbers right here. Let's do print ln so that we get the output in the next line. And let's see now what's happening right here. Okay, we started from 0. These are the milliseconds, right? So I'll write it down here, something that we are printing over here. Notice that the value of mils is increasing rapidly, right? So you can see it's increasing, and it's increasing very rapidly. So what is the mils? It actually returns the number of milliseconds that the Arduino board has been powered up. So I write it down. It returns the number milliseconds that the board has been powered up, right? So right from the beginning, right? So right the time when you power up your Arduino board, it is going to record, or it is going to return the number of milliseconds that the Arduino board has been powered up. Maybe from 1000 milliseconds means a second, and then simultaneously it'll keep on increasing. Actually, the millis number gets very big. It gets very large, right? As soon as the board is powered up, millis function tracks the number of milliseconds is being powered up. It starts at 0 and it counts up and until it goes to, I write it down here, it counts up until it goes to 4 billion 294 967 967 296, which is basically the value of unsigned long. Alright, because we know that int is signed and it takes negative and positive numbers, right? And now what we are going to do, we are going to take only positive numbers, right? And as soon as we start the board, as soon as we start Arduino, it's the millis function starts from 0 and it can go maximum till 4 billion and something, right? You can read it here, right? And it goes till this number, which is basically which is 4 billion, and then it overflows. Then it overflows means it goes till this number and it overflows means it starts again from 0, right? So this is something that we are going to take an advantage of, right? And the best part is it will take 49 days, or we'll say it will take an Arduino timer. It'll take Arduino timer 49 days to overflow, right? Let's wait for a second, Nimal's time. All right. So let me tell you again, Millis returns the number of milliseconds that the Arduino board has been powered up. It goes till this number, which is 4,294,967,296, and then it overflows. It starts again from 0. What is the time it will take to overflow? 49 days to overflow. That means in order for the Millis function to reach this number, it is going to take 49 days to overflow, right? Right. And now how does it track? Basically, I'll just take these things and put it on MS Paint so that I can explain you in a much better way, and share the file as well today. So I'll be sharing the file. Alright, so this is something that we already know, or something that I've already told you about Millis, right? And some more things that are necessary. So let's say note. Alright. So I'll write Millis tracks the number of tracks the number of milliseconds that have passed using the inbuilt timer of the Mega AVR controller, or we can say a controller integrated circuit, which is IC. And we know that Arduino uses 16 megahertz of clock, right? And now at any stage of the program, we can simply call the Millis function and say, hey Millis, please do this for me. And I know that unless I show you something practically, you're not going to get it completely, but so far it's very good. What we've understood, that Millis will return the number of milliseconds that the Arduino board has been powered up, and we can do anything within these milliseconds, right? And we can do everything that we want, and we can do multitasking. We can turn off, let's say turn on the motor. At the same time, we can measure the temperature, and at the same time, we can run an drone or something like that. We can do many things, and we'll do that. We'll do a practical of timed event. So I will do a practical for timed event. Right, practical of timed event using the light resistant diode and the LM35 temperature sensor today. But if you have understood the basics of it, so let me carry on and let me show you how do we do that. Okay, so let me start with an constant integer, or we can say constant unsigned long. Let's see, it's an LDR event and it is going to be 1000, right? So I want to fire an event which is the timed event whenever the Millis function reaches 1000, which is 1 second. So let us do this. Right, and what is unsigned? So I've already told you the story about signed and unsigned, right? A signed integer can store the positive and negative values, right? So I'll write it down here. A signed integer can store both positive and negative numbers, right? And but an unsigned integer can store positive values only. All right, and since we know that we are going to use Millis, and Millis returns let's say about very long, or we can say Millis returns big numbers, so right, so we'll be using unsigned. Okay, signed int can be from -3 to 768 and to positive 32767. So this is what we can store in signed int. By default integer is signed, and I will use unsigned integer. Okay, and it can store from only positive 0 to 65535. So you can see we're storing once we require to store big numbers, right? And we know that we're not going to have any negative value, so we use unsigned long, right? Unsigned int. So unsigned long can store, so I'll say unsigned long can store from 0 to I'll tell you, unsigned long can store from 0 to the exact value what Millis returns us in 49 days, 4, which is 4,294,967,296. Okay, so this is your unsigned long, right? So I hope it's clear, and we'll go back to the program and try and run the program and see what are we going to get if we run this program right here. Okay, so let's say serial.print Millis is not going to work now. So I will say if. So this is the condition which is going to allow us track different events. Unless we know how to use conditional formatting and use the timed events, we will not be bothered about any other things. We will know that we have to handle many things in Arduino. Or for example, if we are using Arduino for an automated project, like I want to control my complete house. At the same time, I have to see whether my gas is leaking or not, right? And at the same time, I have to check the water flow of my tanky, right? I have to autofill tank after every 2 minutes and see the amount of water that I have used. I'm refilling my tank automatically after maybe every 30 minutes. So we require timed events here, right? I have to check, let's say about what is the state of the incoming power or outgoing power. I have to check many different things in a house project or in an automated home automation project. Home automation project can be, we can use many sensors like humidity sensor to turn on and off our fan, accordingly. Or maybe peer motion sensors we can use to detect if someone has passed by or not. If someone is passing by, I can turn on my light, and if he passes by and goes away, I can turn it off. So I'll have to track many events, and if is very essential while tracking those events. So I will use if Millis is greater than LDR event. So we know that initially Millis it starts with 0, and whenever it is greater than an LDR event, I am going to say serial dot print LDR event fired. All right, and let me run it. So you can see after 1 second you'll get it. You can see this. Let me do a print ln. All right, so you can see, but now this event is not firing after every 1 second, because once the Millis reaches greater than LDR event, which is 1000, it'll keep on running, right? So what I do, because I've already written what we are going to learn here, is Millis timeline. So unless we understand what is the Millis timeline, we'll not understand how to use Millis right here. So let's understand the Millis timeline. Okay, let's consider I have a timed event, right, which is in my case LDR event. All right, and I am firing this event right here. All right, at 1000 milliseconds. So I know that, right? So this is my LDR event, and as soon as Millis, okay, now as soon as Millis starts working, starts. As soon as it reaches the timed event, the event is on. What we need to do is, as soon as Millis reaches the timed event, I have to take this timed event quite far, so that the Millis keeps on following the timed event like this. I'll tell you like this. So when I see Millis has reached the timed event, well, I'll take this timed event forward, and if again, let's say Millis follows the timed event and reaches it, I'll again take this timed event forward. So I'll keep on repeating this. Millis reaches the timed event. Let me take this timed event and forward this timed event. You can see this, I forwarded it. Now Millis will start following the timed event again. So as soon as Millis reaches the timed event, I will take this timed event, and I'll take this timed event and put it far on the timeline. So this is what the Millis timeline is. Again, my Millis function will follow, right? As soon as it reaches here, I'm again going to forward and increase the timeline of the Millis function, so that it keeps on happening again and again. But in our case, you can see it's not taking 1 second. You can see clearly it's more than, 10 times in a second. So I do right here, to control the timeline of Millis, I will just do 2 different things right here. Okay, you need to see this, and if you understand this, you'll understand every single thing right here, right? So let me show you this again. I say when Millis gets to the event, which is the LDR event, then do something and also update the time event so that the event runs repeatedly, right? So you have to repeat the event. You don't have to make sure that, okay, once the event has fired and then nothing else will happen. No, you have to run it repetitively. It has to be repeated. right? For example, I want to read temperature sensor value every 10 seconds, so it will repeat after every 10 seconds, all right? And for that, we have to understand this timeline. And to understand this timeline, I will do two different things once again. All right, so what I do right here, I will make unsigned long previous time. So I made previous time, okay? Okay, now what I do here, I will say inside the loop unsigned long current time is equivalent to millis. So which means whenever loop runs, right, I am going to assign the millisecond, the current mils or the current millisecond timer to this variable current time, right? So it's going to get the current milliseconds timings every time I run the loop. So it'll keep on running and giving me fresh and updated timeline. So wherever I'm on the timeline, I'll get it by calling the mils function or by directly calling this current time. So it's very important. So let's say if whenever this current time is greater than or equivalent to the LDR event, right? Or we can say now, whenever this current time is greater than an LDR event, do something. But this is also not going to solve my problem. I will say whenever current time minus the previous time. And this is the trick here. Current time minus previous time is greater than an LDR event, then do something serial dot print LDR event fired. Alright, so it's as simple as anything. And what I do right here, I will say previous time, which is right here, and I'll say previous time is equivalent to current time. Now see what it does actually, right? So first let me show you the output and then I'll make you understand. Now you can see 1 second's interval. Okay, let's see. Okay, just a moment. Okay. I don't know whether uploading is done. Okay, have I assigned? No, previous time is not having anything. I'll say previous time is equivalent to 0. I have to start previous time and assign something. Okay, let's start it again. Done uploading. Okay, serial.println. So let me see. Current time, which is millis, minus the previous time whenever it is greater than an LDR event, which is 1000 milliseconds. So you got to say serial.print LDR event fired, and previous time is equivalent to the current time. So let us see. Alright, so let me show you. Not getting anything. Something is unsigned long current time is equivalent to millis, and unsigned long previous time is equivalent to 0. And I say if current time minus the previous time, which is 0, is greater than LDR event, so which is 1000, okay, greater than or equivalent to, and then serial.print LDR event fired, and previous time is equivalent to current time. So it should work. I don't know what is wrong with this. Alright, I might have to restart the Arduino, and let me do that. Okay. Alright, so it had a mistake that we are updating it outside the if. Now let us see. Now you can see it here, right? LDR event fired after 1 second. But what if I want to do something like this? Now you can see that this is going to be updated after every 1 second because you're taking it away from the timeline. Now you're taking care of the timeline. Now you can see no down, LDR event fired. Now you say previous time is equivalent to the current time, which is 1000. LDR event is 1000, previous time is initially 0, right? And then you are updating it accordingly, right? So let us see now what is happening right here after I upload the program. Okay, done uploading. Now see. Now you can see this 1 second. It's coming after every 1 second. 1 second. So we have successfully made a timed event and we are not using delay. You can see we not use delay. So if we can use this without delay, we can use many if functions to create timed events right here. Now let us see practically what is happening here. Now how much is current time when you load your program for the first time? Current time is going to be given by Millis, which is always going up. So it is always going up, minus previous time, which is 0. So it is going to be currently, it's going to have nothing but only the current time. Minus 0 is it greater than, whenever it goes greater than LDR event, then whenever Millis goes greater than 1000, it is going to print LDR event fired. Then what is in previous time? 0. And it takes the current time, which is whatever the current time is. So let us take an example and let us solve it using MS Paint. Alright, okay. I have defined unsigned here also so that you don't face any problem. Okay, let us see. Alright, since we know that current time initially has, it's always going up, so I'll use this arrow right here. So it's always going up and previous time is 0, and whenever 0 grows greater than 1000 initially, so we are printing LDR event fired. Let's assume current time is 1111. Let's assume for the sake of this class. Okay, and previous time is initially 0. So then you say current time is previous time is equal to current time. So previous time, which has 0, is now having 1111, right? So now you can see if current time minus previous time, okay, right, minus previous time is greater than, now you have to again do the minus of it, right, because whenever it goes greater than, let me give you an example right here. Current time minus previous time is greater than, so whenever it's greater than LDR event, which means it is 1001. The 1001 is greater than or equivalent to, let's say, but it's also equivalent to, so let's say whenever it goes 1000, because it's greater than or equivalent to. So you're printing this, and previous time is equivalent to current time. So what is the current time? 1000. Now previous time will take 1000. So 1000, okay, and now Millis runs again. So you start the Millis function again, and this is going up, this is going up, and this is going up. So let us say it reaches 1500. What is 1500 minus 1000? Which is 500, right? So this is how you are going to take it on the timeline. You are moving Millis on the timeline, okay, right? So it has reached 1000. So it has reached 1000. All right. So you are taking the 1000 far away, and the Millis follows it. As soon as it reaches 1000, you are again taking it forward. So this is following the Millis timeline. So let us do another experiment right here. Let us say what is in the previous time. So I will say serial, let us say serial dot print ln. So let us say previous time initially. Okay, let us upload and see. Okay, let's see now. 0, 1000, 2000, 3000, 4000, 5000, 6000, 7000. You're updating the previous time again and again, and let us say what is in the current time. So first we are going to get current time, and then we are going to get previous time. So this is how you are separating it on timeline. Okay, 1000, 0, 2000. You can see previous time is always going to be, so you are separating it. Now you reach 7000, reach 8000, reach 8000, reach 10,000. Alright, so now what is happening right here is, I'll define it right here. Okay, let us see. This is the timed event. So what is the first one? You can see first one is the current time and second one is the previous time. The current time is 7000 and the previous time is, right, the current time is 8000 and the previous time is 7000, right? And what is basically 7000 minus 8000? That is exactly 1000. Okay, so what you are doing, if current time minus previous time, which is 8000 minus 10,000, is greater than or equivalent to the LDR event, which is 1000, then do this. All right, so it will take 1 lap or 1 second for it to be equivalent to this. So what you have done, you have created a timed event right here. So let's say we have to create another timed event right here. Okay, so I will say if current time minus, so let us say unsigned long previous time 2. Okay, so I'll say previous time 2, and I create another event which is temp event, temperature sensor event, and LDR event. So now let us see, will we be able to do this? Right, so, and this is a timed event that I want to happen after every let's say about 50 microseconds, okay, or 50 milliseconds. Okay, and this is the temperature event, previous time 2 is equal to current time. So let's see now, will I be able to handle 2 separate events? Alright, so let's see now. You can see this right here. Okay, on previous time 2, current time minus previous time 2 is greater than temp event serial.println LDR. We are filing again LDR, so I'll say temperature event fired. You can see both the things, the temperature event fired, we have kept it too fast, so let me keep it 1500 so that we'll be able to see it after every 1.5 seconds. Okay, let's see now. LDR event, temperature event, LDR event, temperature event, LDR event, temperature event, LDR event. So what we have been able to do successfully is to have 2 timed intervals repeatedly. It's repeating, it's not stopping. Repetitive events, and what we have been able to do is stop using the delay function, and we have been able to successfully fire 2 timed events, which now in the next video inshallah we will be doing it again. I'll make you more things, I'll explain more things about the timed event. So let's have a recap. Alright, so we started with Mills. What is Mills? I have written it down here. It tracks the number of milliseconds that have passed using the inbuilt timer of @mega, or we can say it returns the number of milliseconds that the Arduino board has been powered up. It counts till 4 billion, above 4 billion, and it overflows, means starts again from 0 after 49 days, and it gets really big. The Millis number gets really big as this. All right. And what is the Millis timeline? We have to make sure that we are following the Millis timeline. As soon as it reaches the timeline, we have to, right, distance the timeline so that the repetitive event happens. So how do you distance? All right, we distance by giving previous time the current value after every single loop, so that it's basically repetitive, right? And at the end of the day, we have been successfully able to fire two events, right? Or we can say we've been successfully able to fire two timed events, which we will do in the next video. Inshallah, we will be doing it practically. We'll be assigning one LDR and one temperature sensor, and we'll be taking values, real-time values, by using the Millis function, right? Okay, bye bye, take care.